think I covered most of this stuff with you in the last time. So let's just talk about this. When we talk about order, the order of a matrix, what are we talking about? Yeah, we're talking about just row by column, right? So I want to make sure that I cover that. So if we say, matrix A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 0, 2, okay? What is the order of this matrix here? Yeah, the order is a 3 by 4. It always goes 3 rows by columns, right? So I've got 3 rows and I have 4 columns. And then what do we call each individual element in the matrix? There's a word for it, remember it? Starts with an E. An entry. It's just an entry, okay? And the way that we describe an entry is usually with a capital A, and the book uses these subscripts I and J. What do you think the I and the J stand for? The rows and the columns, right? So how would I describe that entry that I just circled right there, that's 7? How would I describe that? That would be a row, it goes row by column. So row 2, right? Column what? Column 3. There you go. So that would be entry A23. Does that make sense? Row 2, column 3. What is this entry right here? A what? Row 3, column 1. Very good. Okay, what about this entry over here? What would that one be? A14, right? That doesn't mean A14 or anything else. That's just that stands for, rows and then columns. So keywords here that we have to remember is the order of a matrix is its dimensions, basically a 3 by 4, and the way that we describe elements in the matrix, those are called entries, and we describe them by the subscript of row and then column. Okay, so how do we know if two matrices are equal to each other? Two things have to happen, right? What has to be true? Huh? Same solution set? Not necessarily. Well, I guess so, yeah, same solution set. But if we weren't solving anything, just how do I know that this matrix and that matrix are the same? So, like, as an example, right? If I give you this, x and 5 is equal to 7 and y, what would x have to be? Yeah, this is not a trick question, right? X has to be 7 and y has to be what? 5. Okay, so what is the order of this matrix here? What is the order of that? No. How many? It's rows by columns. This is a 2 by 1, right? Okay, what is the order of this matrix here? Also a 2 by 1. So there are two things that have to happen in order for matrices to be equal. Can you think of the two things that has to happen in order for the matrices to be equal? The first thing and the second thing. Huh? There you go. The first thing, they have to have the same order. Okay? And they have to have the same what? Same entries. There you go. But not just the same entries. They have to be corresponding entries. What do I mean by that? What do I mean by corresponding entries? Like, is this, like here's an example. Okay, 1, 2, 3, or I should do this. I should do this. 2 and 1. Are those the same matrix? No, they're not the same. Those two matrices are not the same, right? How come? They have the same order, and they have the same entries, but they're not corresponding. Do you see the difference there? They're not corresponding, right? So this entry, this is row 1, column 1, needs to be a 1, and over here it's a 2. So these are not the same. But if I did this, and I did 2, 1, then all of a sudden these two are the same because they have the same order and they have the same corresponding entries. Is that pretty straightforward? It's pretty straightforward, right? Okay. Okay, so I'm telling you that these two matrices are equal as defined by the equal sign in between them. They're both a 2 by 2, so your goal, your job is to figure out what the values of x, y, and z are, okay? Give you about 2 minutes, you should be able to do it. We're okay with this. Who's got a good answer here? Who wants to share it? What do they got? Okay, Lauren, what'd you do? Yeah, so x is 12. That one's pretty straightforward, right? You just say, well, it's in the corresponding spot, so x is 12. And then we set y plus 3 equal to 5. And we just do a little algebra. So y plus 3 is 5, so y has got to be 5 minus 3, so y has got to be 2. Right? Good with that part? And then you did what? 2z, so then z has to be 3. Okay? So our answers are x. 8? Well, that we don't need anything for that. The 8 is just showing that this entry and this entry are the same. That's all it's doing. We don't really need to use that one in this particular problem. So for matrix operations, right? Matrices are just full of numbers. And so they behave almost exactly like the same way regular numbers do, with a couple of nuances that we have to take into account, which we'll learn tomorrow. So let's think about the operations that we can do on a matrix. We should be able to add and subtract, multiply and divide matrices, assuming that we can take into account, any areas where we'd be multiplying by 0 or anything like that. So basically what we can do with regular numbers, we can do with matrices. And the two real easy examples of this are adding and subtracting matrices. It works a little different from multiplying, and we'll get into that, but adding and subtracting is very, very straightforward. So here's what we're going to do. So we're going to let matrix A be this matrix here. 2, -1, 0, 3, 4, and 1. Okay? And we're going to let matrix B be this other matrix over here, which is 6, 5, 1, 3, 0, and 8. So to begin with, what is the order of matrix A? Matrix A has how many rows? 3 rows, 2 columns. What's the order of matrix B? 3 rows, 2 columns. So it's very important to begin with to note that in order to add or subtract matrices, what has to happen? They have to have the same order. Otherwise, we can't do it, right? Because we have to be able to add or subtract corresponding entries. And if there's no entry corresponding to one matrix to the other, then we can't do it. So we have to begin by noting that their order must be the same. So I just say down here, order must be the same. Okay? Otherwise, we can't even continue. And all the problems that you're going to get, the order will be the same. But it's important that you know that. So let's do a couple of these together. I got a couple of examples. So we'll do example A. All right? What would matrix A plus B have to be? And this is not nearly a trick question. I'm just, do exactly what you would think you should do. What do you think if I'm adding a 3 by 2 and a 3 by 2, what should I expect to get? Another 3 by 2. So I'll go ahead and make my 3 by 2. I want to just add these together, so I would add corresponding entries. So I'd go ahead and add 2 and 6, and I would come up with 8. I would go ahead and add -1 and 5 and come up with 4. 0 and 1 and get 1. 3 and 3 and get 6. 4 and 0 and get 4. 1 and 8 and get 9. And yeah, it really is that easy. And it's allowed to be that easy. That's all we got to do. Okay? So what about matrix, what if I, example B, what if I did A minus B? Okay? Again, not a trick question. Just do what you think you should do. So 2 minus 6, what would that be? -4, -1 minus 5, -6, 0 minus 1, -1, 3 minus 3, 4 minus 0, and then 1 minus 8. Yeah, it's really that easy. That's okay. It's allowed. All right. And then what do you think I would get if I just did matrix B minus A? What do you think I would get? No, let's do it real quick. Find out. Okay. Let's do B minus A. Let's do 6 minus 2. What would that give me? Yeah, that'll give me 4. Okay. What's 5 minus a -1? 6. Okay. What's 1 minus 0? 1. 3 minus 3? Yeah. 0 minus 4? -4. 8 minus 1? 7. What do you guys notice? You guys notice anything? Yeah, every entry is opposite the one that it gave to me. It's kind of interesting for this particular example, right? Kind of cool. I like that one. Okay, so your calculator can also do this. So I do want to show it to you at least once. So take your calculators out for me, please. Okay, so I do want you guys to have calculator skills when we're talking about matrices. So we'll go second matrix, and we're going to go over to edit. And we're going to plug in matrix A. What's the order of matrix A? A 3 by 2. So go ahead and enter a 3, enter, 2, enter. And then plug it in what it is. So I have a 2, -1, 0, 3, 4, and then a 1. Alright, does that look good? Yep, it all looks good. Once you have matrix A stored in your calculator, you can go ahead and quit and do second quit. Get yourself out of it. Whoa, where'd this thing go? don't know why it does that sometimes. Okay, there we go, good. So then I want to do a second matrix, and you actually want to enter in another matrix, and you want to enter matrix B, so you have to go down to matrix B to edit it, okay? And then this is also a 3 by 2, so 3, enter, 2, enter. Okay, so I'm going to punch in matrix B, so it's 6, 5, 1, 3, 0, and 8. So far so good? Okay, good. Now hit second quit, get yourself out of that. Now I actually just want A plus B, so you enter second matrix 1, and notice it brings you back to the home screen, and then you just hit plus. You know, you do exactly what you'd guess you'd think you'd do. Second matrix, which one do we want now? I want 2. I want A plus B. Pushing enter, I get 841649, 841649. It's exactly the same thing that we got here. And guess what? If we did the same thing for the other two, it would exactly be the same thing. I don't want to waste your time. But do you guys get the concept behind that? Yeah. All right, cool, right? Okay, last idea that we're going to talk about today is it's called scalar multiplication. Scalar multiplication is just taking a matrix and multiplying it by a constant, which is known as a scalar. So as an example, let's let matrix A be the matrix 4, 1, 2, and 3. Okay? What's the order of matrix A? Yeah, this is easily a 2 by 2. Okay? This is a 2 by 2. And what I am interested in right now is what would 4A look like? What would 4 times matrix A look like? Exactly. All that means is we take the number 4 and we multiply it by matrix A, which is defined as 4, 1, 2, and 3. And you're exactly right. You just multiply every entry by that scalar of 4. So it doesn't make a 2 by 2 an 8 by 8, right? It makes a 2 by 2 another 2 by 2, but every entry is twice or 4 times what it was before. So as an answer, I'm thinking I would get like, what, 16, 4, 8, and then 12, right? Okay. So what would negative 3A be? Negative 12, negative 3, negative 6, negative 9. Okay. So that is scalar multiplication. It works just like you think it would. Okay? So the other two things that I have not yet talked about is how to multiply two matrices and then find inverses of matrices. So that's going to be tomorrow, all right? So far, here's what we can do. A little bit of review for everybody, right? We can find the order of a matrix. We can talk about its entries. We can tell if two matrices are equal by their equal entries and equal order. We can practice that. We can add or subtract matrices just by adding or subtracting corresponding entries. And then we talked about scalar multiplication.